How to install a septic system. Private on-site wastewater treatment systems, POWTS, more commonly referred to as septic systems, are used primarily in rural areas of the country where wastewater treatment is not available. These systems fall into two general categories: 1. Gravity-fed conventional, and 2. Alternative, pump, systems including aerobic treatment units, ATUs. Alternative systems usually include electric pumps. This is a project recommended for a professional with experience in the field due to the potential risk to environment by pollution of the watershed. Yet, it is still possible in many health jurisdictions in the USA for an individual property owner with skill sets in heavy equipment operation to use a backhoe to install a septic system. Steps. 1. Prepare and design your system. The first step in any septic installation is to perform a site survey and do a percolation, soil, test on the area where the POWTS is going to be installed. The system then can be designed based on the findings of the survey and results of the soil test. After this, the appropriate permits and approvals can be applied for. Site survey findings that influence the design include things like available space, topography, intended purpose and perceived water use based on the size of the building the system will service, location of the well and/or neighboring wells. Soil test findings that influence the design include things like soil type and layering, sand, clay, rock, and where it is located relative to depth. Ability of the soil to drain and filter wastewater. 2. Wait for approval. Upon receipt of the necessary permits and approvals, the system can be installed. Be sure to perform the following procedures in compliance with any and all laws and applicable plumbing and building codes. Method 1. Gravity-fed system. 1. Assemble the equipment and tools needed for excavation. You will need backhoe, laser transit and grade pole. For SCH, 40 PVC pipe and fittings if needed. For ASDM D2729 perforated pipe. For ASDM D3034 pipe and fittings. For SCH, 40 vent caps and test caps. PVC primer and glue. Saw, either hand saw or cordless recipe saw. Hammer drill and bits, to go through wall if necessary. Hydraulic cement, to seal around pipe if going through wall. Shovel. Inch, and half-washed stone, quantity depends on system size. Tape measures, regular and also at least a 100 tape. Septic fabric, cut roll to 3 long or so. Septic tank and risers, concrete or plastic if allowed. Seal, for concrete, or silicone caulk, for plastic, to seal risers. Septic filter, Xoller 170 or similar, if required. Distribution box, either concrete or plastic, if running more than 2 laterals. 2. Find where you want to go into the building relative to where you want to place the septic tank. Excavate to at least 2 feet deep and drill a hole through the wall, or go deeper and go under the footing, whichever is desired or necessary. Plan for the flow to go downhill from here, as this is exactly what a gravity-fed system is all about. It does not use a mechanical means other than gravity to discharge the waste from the tank to the drain field. Pipe for SCH, 40 going a foot through the wall or under the footing, and to a minimum of 5 feet outside the building toward the tank. Set it level where it's going through the wall or under the footing, and from there run with about an 1/8 per foot of pitch, slope, toward the septic tank. Go further or all the way into the tank if required. If not, switch to 43034 with the appropriate adapter and pipe toward the tank with 3034. Be sure to put a test cap on the end going into the building. If going through the wall, seal around the hole with hydraulic cement, inside and out. Don't run too much pitch going out to the tank. If there's too much, the water runs away faster than the solids, and the solids may get left in the pipe. Also, there may not be enough pitch to get to the drain field, depending on the depth your drain field is, and how close it will be to the outlet of the tank. 3. Excavate a hole large enough to set the concrete aerobic tank below ground. Use the laser transit and shoot the top of the pipe going out to the tank. Measure the distance from the top of the inlet to the bottom of the tank. Add this, go up on the grade pole, +112, to the number you shot off the top of the pipe. The grade pole is now set to the depth that you need. Proceed to use this to excavate the hole to the appropriate depth. Lay out and excavate your leach field as it has been determined by the test done in the permit process. When laying out and excavating, remember to maintain a positive flow between the tank and the drain field. 4. Place, in most jurisdictions, inch and a half-washed drain rock from a nearby gravel pit around the pipe. This is required to hold the pipe steady. See your local health requirements for the size of embedment needed and the size of gravel. The perforated pipe in a gravity drain field has no slope end to end and has capped ends. 5. Cover up the pipe and tank once you have a green tag from the health inspector. All areas depending on the rules of the local health department will require a special filter fabric, newspaper, 4 inches of straw or untreated building paper to cover the drain rock before backfilling. Method 2. Alternative septic systems. 1. Install a pump chamber after the septic tank. The pump chamber, or sometimes known as a pressure tank or dosing tank, contains the electric pump which is utilized to move the effluent from place to place, and eventually into the drain field for final disposal. Set up the pump chamber as you would the septic tank. The pump chamber contains the effluent pump and floats to pump out to the drain field at measured or timed intervals. This is a sealed system. The electrical installation will usually require a licensed electrician to satisfy state regulations. In areas with high groundwater, be aware that the pump chamber or additional ATUs may be mostly empty much of the time, and these tanks may have to be protected against flotation by the use of extra weight or other protective structures. 2. The construction details, including the layout of all sewers outside of the home, the location and depth of all tanks, the routing and depth of pressurized effluent lines, and other system parts such as the drain field and any additional ATUs must match the septic system plans as approved by the local county health department. 3. Cover the tank and pressurized lines once the inspector has given his final approval and the system is activated. Tips. Use of aerobic bacterial additives, available at most DIY stores, periodically claimed by manufacturers to maintain a healthy and properly working system, is controversial. The septic tank is an anaerobic, wet environment where most yeasts and other additives will have little or no effect on the sewage. Some old-school installers want to put an additive, a shovel full of sludge or a dead cat in a new tank to start the septic process. What goes naturally into the tank is all that is required. The aerobic, moist or dry, portion of the system is hundreds of square feet of drain field where additives will not do much good even if they get that far. There is no independent study of the use of additives in septic systems published in any credible scientific journal available anywhere in this country. Your local health department will likely confirm this opinion. Each step of the construction process will most likely involve an inspection by the health inspector before continuing on or covering up the work. The use of a sand embedment is advised on pressurized lines to minimize damage caused by moving soil that has a higher clay content. Pressurized lines can also move when pumps kick on and off. Sand bedding 4 inches, 10.2 centimeters, on all sides of the lines will prevent any sharp rocks from the ground or the backfill from wearing holes in the pipe over the years. Warnings. When installing the leach field perforated pipe, make sure that you do not turn the holes in the pipe downward. The perforated drain field pipe ASTM 2729 has perforations on both sides of the pipe and must be laid dead level with the printed line on the pipe facing up. All sections of the perforated pipe are glued together and the end of each leach line is capped. This way, when wastewater enters the pipe, it will fill the pipe to the height of the holes and overflow from all of the holes using the entire leach field. Placing the perforated pipe at any slope will direct all of the water to the lowest hole in the pipe, creating a concentration of sewage at only a small part of the drain field. You can, in some health jurisdictions, use wastewater for watering grass or ornamental plants, trees, vegetable gardens, and fruit trees. However, the water must be treated first by the system, tertiary treatment including disinfection, to ensure that pathogens, germs, from the septic system are not released to the environment. Check with your local health department to see if this practice known as reuse is allowed in your area. Things. Backhoe tractor. Trencher. Shovel. Contractor's laser level and rod or a surveyor's transit. Septic tanks. PVC perforated pipe. Embedment material. PVC glue. PVC fittings, an outlet filter for the septic tank. Hand saw. Coarse file. Effluent pumps and floats if needed. If an alternative system, a control panel.